So today we're going to talk about solving by factoring. So again, this is a skill that we practiced in our quadratic functions unit. We factored quadratic functions. We got that intercept or factored form, we called it, to be able to find x-intercepts for our function. Today we're going to use factoring as a method to be able to solve these functions. So we're on page 11 in your notes. And our very first example gives us a function in that intercept form equal to 0. And this is, why is this easy to solve? So where we've been solving by graphing earlier in this unit, right? We typically had vertex form. So we could plot the vertex and then use what we knew about the graph to find more points. Here, all we know are the x-intercepts. We don't know the vertex from the form that we have, but we know that the x-intercepts would be -1 and +3. So I have an x-intercept at -1 and at +3. Because the lead coefficient is 1 and positive, I know that this graph is going to open up. So I know it's going to look something like this, but I don't know exactly where the vertex is. This is a sketch. This isn't a point-by-point perfect graph of this function. I know the x-intercepts. I know it opens up. I know the vertex should be down here somewhere. I know I'm going to have more points up here and up here. But all I know for sure, based on the information I have, are the x-intercepts. Since we want to know when this function is equal to 0, it turns out that's actually enough information to be able to give the solutions. So I want to know, when is this equal to 0? So I'm going to go to where y is 0 on my graph, extend that all the way across. And then what I want to know is, where does my parabola hit that line? When my parabola hits that line at my x-intercepts. And that's something that we talked about when we were solving by graphing. When we're equal to 0, our solutions are going to be the places where we hit the x-axis, our x-intercepts. So even though we don't have vertex form to be able to get a great graph of this thing, with just intercept form giving me the x-intercepts, I can solve this because I want to know when it's equal to 0, and those are the x-intercepts. So intercept, or factored form, we've also called it. Intercept or factored form gives us the x-intercepts when our equation equals 0, our solutions will be the x-intercepts. So some intercept or factored form gives us the x-intercepts. If I want to know when that thing is equal to 0, when my quadratic equation is equal to 0, I'm looking for the x-intercepts. My x-intercepts will be my solutions here. So that means that we can use factored form to be able to find solutions for our quadratic function. And that's going to be our focus for today. So if we hop down to example A here, we already have factored form for A. Okay? This is our best case scenario. The hard work is done for us. This is already factored. So from this factored form or intercept form over here, we know that the x-intercepts would be -1 and 5. Now I'm not asking you what are the x-intercepts. This time I'm asking you what are the solutions here. And again, since we're equal to 0, my solutions will be the x-intercepts. So instead of saying the x-intercepts are blah, 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 since I want to know the solutions, I'm trying to solve this, I know that x equals -1 and x equals 5. So my solutions are -1 and 5. Now, I'm not always going to give you factored form. For a lot of the problems that we'll see, we'll have to do the factoring ourselves. So that's the hard part of these. If I take a look at B, I've got my whole quadratic function here, again, equal to 0. Equal to 0 means I can factor this, and my x-intercepts that I get from that factored form will be my solution. So I want to factor this guy. So I'm going to look for factors of 24 that add to negative 11. I know some people liked that X format from Delta Math, where it said, what did we multiply to get 24? And what did we add to get negative 11? So if this X format helps you, great. The other thing we looked at was to make a list. So what times what would give me 24? And we could pick out of our list. So I'm going to make a list. That could be 1 times 24, 2 times 12, 3 times 8. 3 plus 8 would give me 11. Since I want negative 11, let's use negative 3 and negative. So my factored form here would be x minus 3 times x minus 8 equals 0. And then my solutions would be x equals 3 and 8. Questions for me so far on A or B? Okay. Let's take a look at C. Same idea. We need to rewrite this in that intercept or factored form. So I would like you to do that now. Factor our quadratic here for C. Factor our quadratic. So we want factors of 24 that add to negative 10. Since I want them to add to a negative number, just like in B, I need a negative times a negative here. I'm going to do that with part C as well. So negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, negative 4 times negative 6. That will do it. That would add to negative 10. So my factored form is x minus 4 times x minus 6. And our solution then would be x equals 4 and x equals 6. Questions for me so far? Okay. Now, one reminder I want to give you, we saw a problem or two like this in our last unit when I asked you guys about x-intercepts from our factored form or intercept form. In some cases, we're going to have a number in front of x in one of our factors. And so when I have a factored form that looks like this, I can't just look at the other number. My solution here is not negative 3. My x-intercept here is not negative 3, okay? So if I have a number in front of x in one of my factors, set that equal to 0 and get x by itself. Having a number in front of x, having a coefficient for x in a factor, does impact your x-intercepts and does impact your solution. So we need to make sure that we take that into consideration when we're giving our solutions. So I'm going to set it equal to 0, just that little factor, and solve for x. So we get a solution of negative 3 over 2. Not negative 3, negative 3 over 2. Now you could, if you wanted to, set every factor, no matter what it is, equal to 0 and work through those steps to solve for x. We don't tend to do that for our simpler factors, just because it's pretty easy for you guys to get from here to here, especially after we just had a whole unit where one of the things that we practiced was picking out x-intercepts from that factor. Okay, so if you have a number in front of x, remember you've got to account for that when you give your solutions or your x-intercepts. Questions for me on our first few examples? Okay, so turn the page for me, if you will. And now I want to take a look at that example we started with, but with a modification. So this is that same factored form, but I want you to notice this time we're not equal to 0, we're equal to 5. So if I were going to graph this, again, I know that my x-intercepts are -1 and 3. So -1, 1, 2, 3, and 3. Because of my lead coefficient, I know this parabola is going to open up. I know I've got a vertex down here somewhere. But this time, I don't want to know when this parabola is equal to 0. I want to know when this parabola is equal to 5. That's up here. I don't know exactly where those points of intersection are. So I do know that the solutions are not -1 and -3. Those are the x-intercepts, but it's not where my graph is equal to 5. It's not where it's going to intersect with this line of 5. So factoring is a great way to solve if I'm equal to 0. If we're not equal to 0, that's not going to help us, because remember, factored form tells us x-intercepts. If I'm not looking for x-intercepts, then having them isn't very helpful. Okay? So the setup we have here isn't going to give us solutions, because factored form or intercept form tells us x-intercepts. But we, for this problem, don't want to know when our equation equals 0. We want to know when it equals 5. So as we're looking at solving by factoring, if my equation's not equal to 0, I need to move some things around. Okay? So if we're going to use factoring as a strategy, I need to have all of my terms for my quadratic equation on the same side and then equal 0. If it's not equal 0, it doesn't matter what factors I have. Okay? I'm not going to be able to see my solution. So if we take a look at the examples a little lower down on page 12, notice that for each of these, my equation is sort of split across the equal sign. So for all of these, we're going to move everything to the same side and then factor. So for A, my first step here is going to be to move this 3x over to the left. I want everything on the same side equal to 0. So this would be x squared plus 2x minus 35 equals 0. Once it's equal to 0, now I can solve by factoring. So I want you to go ahead and find factored form for A. Find factored form for A. Remember, factors of -35 that would add to 2. Mm-hmm. 7 times -5 would give me -35, but if I add them, they'd give me 2. So my factored form would be x plus 7 times x minus 5. Once I have factored form, I can see my solutions. So my solutions will be x equals -7 and x equals 5. Very good. Let's take a look at B. I need everything on the same side equal to 0. So that means I need to move this 6 over. So I have x squared plus 3x minus 18 equals 0. So factors of -18 that would add to 3. Find your factored form. Do you have it, Hannah? Yeah, factors of -18 that would add to 3 would be 6 times -3. So our factored form would be x plus 6 times x minus 3. And our solutions then would be -6 and +3. Questions for me on A or B? Okay, let's hop down to C. So for C, again, I want to move everything to the same side. I'm going to move everything to the x squared side. That means I have to add 18 and I have to add 9x. Now, when I rewrite this, I want to make sure that I'm writing it in standard form. So I want the x squared term first, then the x term, then the constant term. I want standard form so that I can factor. Now that I have everything on the same side set equal to 0, you can find your factored form. So factors of 18 that add to 9. Factors of 18 that add to 9. Go ahead. 3 and 6. Yep, factors of 18 that add to 9. 3 and 6 or 6 and 3. That order is not important as long as you have both of those factors. So x plus 3 times x plus 6. And my solutions then would be x equals -3 and x equals -6. The last couple of examples that we're going to look at are a little bit tougher factoring problems. So we're going to solve them the same way, get everything on the same side equals to 0, factor, and then get our solutions from our factored form. Just the factoring process is going to be just a little bit trickier on the last couple. So on D, what's my first step here? I want to solve by factoring, so what do I need to do first? Yeah, move everything to the same side. So I'm going to move this 33x over. So I have 3x squared minus 33x plus 72 equals 0. Now this time we have a number in front of x squared. We have a lead coefficient that's not 1. We see something in front of x squared. That means that I can't just look for factors of 72 that add to -32. Our first step instead, when we see a problem like this, is to check to see if this lead coefficient is a GCF. Is it a greatest common factor for every term of this problem? Can I evenly divide the other coefficients and constant terms by 3? So can I take -33 and divide by 3 for no remainder? Yep. How about 72? Yeah. So that means 3 we can factor out of here as a GCF. That's going to make this problem a little bit easier to work with. So I'm going to pull my 3 out in front, since it's my common factor, and then I'm going to write what's left over. I divide that out of each term. So this would be x squared minus 11x plus 24. That's what's left over when I divide all these terms by 3. And now this thing we've actually already factored today. Factors of 24 that add to -11. That would be -3 times -8. So this would become x minus 3 times x minus 8. Still have our GCF in front there. And so my solutions are x equals 3 and x equals 8. So we have a number in front of x squared, a lead coefficient that's not 1. Check to see if it's a GCF before you do anything else. Questions for me on D? Yeah, so when we're finding solutions, we're finding them from factors that have an x in them. 3 doesn't have an x, right? So if I tried to set that equal to 0, like we said, we could put x minus 3 equals to 0 to solve for x, and x minus 8 equals 0 to solve for the other x. If I put 3 equal to 0 here, there's no x to solve for. This is just like gibberish, since we know 3 is not equal to 0, so I don't have to worry about it. Now, if I pulled an x out as a GCF, let's say our GCF was 3x, then I have an x to solve for. So I would need to solve for x there, but that's not what we have here. Good question. Other questions on D? Okay, let's hop down to E. What's the first thing I need to do on E? Move everything to one side. So I'm going to move this 7x squared over. This would give me x squared plus 3x plus 1 equals 0. And now I want factors of 1 that add to 3. Factors of 1 that add to 3. Yeah, this is, so to get 1, that could be 1 times 1 or -1 times -1. Do either of those options add to 3? No. So we saw a couple of problems like this in our last unit when we were first learning how to factor. And we said for a case like this, we simply said there were no integer factors that we could use here. So I can't write this in factored form because I don't have integer factors to give a factored form for this. So since we're solving now, instead of saying no integer factors, we're going to say no integer solutions. Okay. So for E, no integer solutions. If I can't find integer factors to write factored form, that means I'm not going to have integer solutions. And then our last example for today, we're looking at F. My first step is to move everything to the same side. Move the 16 over. We have 3x squared minus 8x minus 16 equals 0. I have a number in front of x squared, the lead coefficient that's not 1. First thing I want to check, is it a GCF? So is 3 a GCF for this problem? Nope. I can't divide 8 or 16 by 3. I would have remainders there. So I can't factor it out the way we did in D. That means that as I write my factored form, one of my factors is going to start with a 3x, and the other one will just start with x. So these were the little bit tougher problems to factor because we had to do a little guessing and checking here. So I'm going to need factors of -16 that I can fill in here so that when I distribute, I get -8x in the middle. So my factors of -16 would be 1 times -16, or -1 times +16, 2 times -8, or -2 times +8, or we could do +4 times -4. Anybody have something they would like to try? I think it sounds good. Let's give it a shot. 2 times negative 8. Do you want the 2 here or here? In the front? So if I distribute this, I would get 3x squared minus 24x plus 2x minus 16. So this would be negative 22x. That one didn't work. Let's try something else. For a negative 4, where do you want the positive 4? In the first one or the second one? You want plus 4 back here? Okay, let's give it a try. So 3x squared plus 12x minus 4x minus 16. I got our 3x squared here. So this would give me plus 8x. Right idea, but wrong sign. Let's switch those signs. Let's try plus here and minus here. That would give me 3x squared minus 12x plus 4x minus 16. That gives me negative 8x. That's the factored form I want to use here. Remember, guess and check is okay. Try something. If it doesn't work, try something. So our factored form here would be 3x plus 4 times x minus 4. Now that I have my factored form, find our solutions. Since we have a number in front of x in this factor, remember that means that I've got to set it equal to 0 and finish solving for x. So I get 3x equals negative 4. And then x equals negative 4/3 for my first solution. For my second solution, I would have x equals 4. Questions on our last example? On the next page in your notes, on page 13, you have 6 practice problems. This is what I want you to work on for homework tonight, okay? 6 practice problems. Remember, we're solving by factoring here, so I need everything on the same side equal to 0, okay? Everything on the same side equal to 0. Then find your factored form to get your solution, okay? So page 13, 1 through 6 for homework.